Okay, so today, the first hour, we will still doing this programming work through, so you can get started with the programming. The next hour, you will be working on your own for real single cell data analysis using gene expression analysis tools. Okay. So I hope everyone get this print up. You have the interface. You're ready to type in comments.
I accidentally saved the image file last time. Could someone give me the map file?
Which file?
When we were all working with the same data set, I accidentally saved like an image into my computer.
Oh, yeah, we don't have to work on the same
Okay.
file. So next hour, the second hour, you will work on your own data. So look at the paper and in your field and download the data, then you save it. Yeah, so we're not going to work on the same data set, but if we have the same ID of the data set, we can download the same data set. Mm-hmm. Again, I think the best place to start with this is getting started with MATLAB. So last time I talked, you should offline and do your homework and work through some of those examples. I think as a group, we still work some of them and highlight some key points. And then after this, we will look at some of those computation we mentioned during the lecture. And then, for example, multiplication of the matrices. And then use MATLAB and to see, to help us understand those concepts. Okay, so I will click this, start with examples, for some examples here. Let's see matrices and arrays. Okay, so you type in this 1, 2, 3, 4 that give you a vector A, this 1 by 4 dimension. So I can easily do this here. Okay, 1, 2, 3, 4. I can put a comma next to each element. They are the same. Okay, you gave a space or give a comma to indicate the separation of those elements. If you want to type in a matrix, so you use this semicolon to separate from one row to another, okay? So that's what I'm going to do. If I change one of these to semicolons, I will get, instead of 1 by 4 vector, I have a 2 by 2 matrix. What if you type in something like this? You miss one element. This will not work because you have to have the same element each row in order to make it rectangular, right? You cannot see, okay, I want to do one more here. Yeah. I think if you have R background, it's very similar, right? In Python, any language. Of course, normally we don't type in all the data. So sooner or later, we will have a function to read those data points from files, okay, different kinds of files. Because those files in the text format or in Excel spreadsheet, the format, there are many different kinds of formats. So it's difficult for IO function, input-output function, to read those arbitrarily defined files. So it's a little bit harder than this, but for now, you just need to know how you type in those numbers in this way. A question for you: if you have a vector, say A goes 2, 1, 2, 3, 4. So this is a 1x4 vector. Can you make it 4x1? Okay, how can you transpose it? And try A and it becomes B. Okay, this should work. Or you can do, just put a apostrophe in there, like a shortcut operator to transpose it. The same rule apply to matrix. So you can put a apostrophe upon this variable, and then you will transpose this. So this gave you 1, 2, 3, 4, and this gave you the transpose. All right. So if you have a matrix, see, I read in a matrix is gene by cell, and all you have to do is, in order to transpose into a cell by gene, just put this apostrophe at the end of your variable. It will just transpose the matrix. Okay. There are sometimes you need to define special vectors or special matrix like this. You want to have a vector of zeros, 5 of them, 5 in a row. So this is a shortcut to create that instead of type in 5 zeros in the squared blocker, and just uses a function to return a 5x1 vector filled with zeros. So you can try, for example, and use this addition operation to add a value of 10 to all the elements in the matrix. Okay. Now I give you a question. So if I have a, so 1, 2, 3, 4, if I a plus 10, I will add 10 to every element in the matrix. What if I want to add 10 to only one of the elements? See, I want to add 10 to this number 2. How can I do it? If you do a plus 10, it will become this. Now I want you to add 10 to this number only. So anyone knows answer, just type in the chat. Brennan is good. So you add another matrix, which this matrix all zeros, but that corner is 10. It's a very smart way to do it. Yes. Anyone has any other solution? So that's Brenna's solution to add. She make a new matrix. Okay. So we can do this. So that's 1, 2. Plus 10. Okay. So for the same problem, we have 2 algorithms. Okay. Bring up this solution is to build a new matrix, and this new matrix plus the old matrix and superimpose onto it. And this new matrix only have one element plus 10 or 0. The solution I provide is to first extract that element value and make plus 10 and put it back. Okay. I'm sure other people have other solutions, but that's the way to illustrate different features of this. So that's multiplication between 2 matrices, not multiplication, addition of 2 matrices, element by element. And my solution is to show you how to extract a value from the matrix and put it back. Okay. So now I make a change on the A itself. So if I don't put it back, the answer will just print out on the screen, but I can give it to another matrix. Let me see if I can do it. No. So if I don't put it back to A, it will just print out the answer on the screen. Your original A is still the same, okay? Unless you put it back. Okay, next topics. So those are the built-in functions, sine, cosine, and a lot of those functions will apply to matrix, and then the operation will be element-based. So this sine will operate for every element, even with you don't need to do any looping. Okay. This is a transpose. It showed you. Okay, so this example show you a matrix A multiplied by its inversion. Inversion you can think about as a, if it's singular scalar number is 1 over this number, right? But for matrix, it's not 1 over the matrix, it's an identity matrix of the same element, same dimension over that matrix. Okay, so if I want to create this identity matrix, this function is called I. If I have 2, so this return your identity matrix. So if I use this to divide A, I'm not so sure whether this will work. Let me think. So that division between matrix, yeah, it also works. So this times A, you see what I'm doing here is just to show you the inversion of the A is the identity matrix divided by that the matrix. So every operation here is matrix based. Not so sure whether you get this. Almost. You see this difference is a small number and 10 to the minus 15. So that indicate this answer is the same as that answer. Okay. Yeah, another way to do this is -1. So I'm showing you several different ways to do the inversion of a matrix. Our matrix is 1, 2, 3, 4. Our matrix normally use A, 1, 2, 3, 4. Okay, if you want to do the inversion of this, this one way. That's what I'm doing there. And using function inversion A, you get the same answer. I use a definition to do this. 1, 1, 0, 0 divided by A. I got the same answer. Okay. So the inversion of this is that number -2, 1, 1.5. Okay, that's this inversion of this function and also so So A times its inversion A equals 1, 1. Okay. So this format indicate you want to know to get a higher precision of this numeric answer. When you do the short, it will be more concise. Okay, so if I have two matrices, and in this case, A small a is a matrix. Here we have this dot and the dot product. In MATLAB and also in Julia, once you have this dot operation, that means element based. So I will show you if in my case here, my A is this. If I do A dot multiplicate A, that's element based. So 1 times 1 is 1, 2 times 2, 4. Okay. And this is normally is not equal to matrix multiplication results. So A times A in the matrix multiplication operation we discussed during the lecture, and that's not element by element based, but once you put a dot here, it's element by element. Okay. So anyone can tell me the answer of this? A take the power squared, but it's element by element. So the answer is will be the same as okay. Is this the true squared? It is. Okay. So this is a matrix multiplied by another matrix because it's the same, so it's self squared. Matrix squared matrix. Any questions so far? concatenation. So if you want to combine these two matrix side by side, you just put them into a square block and the squared brackets. And A is on your left and on your right is another matrix. Put them together. So this again is a horizontal concatenation, and then if you do the semicolon, the first matrix and the second matrix will be one on another top. So that's vertically and concatenated. In single cell study, we don't use complex number. So I will skip this. Well, in the quantum computing, we use a lot because it's so convenient once you have this. Okay, so we are done with the first section of this getting started with MATLAB. If you have any questions, please let me know. We are moving to the array indexing, so just matrix indexing. I showed you a little bit by okay, how can I extract the value from the matrix by its coordinates, by its index, and add 10 and put it back. So the same idea here. So let's make this matrix here, big A. Remember, in order to extract the value from particular element, so you use this round bracket and then put the coordinate, the index, this two-dimensional matrix. So we have number by 4, so that's row first, 1, 2, 3, 4, and the second column. Fourth row, second column, the value is 14. So once you type this, you get the answer of that. Okay, so if I can get 14 here, but if I decide to see, I want to put this as -1. Okay, now I'm assigning a new value to that particular element. So that gave you a replacement of this value. I can do something So anyone can, maybe I'm not so sure whether this will work. So now I'm doing, let me think whether this will work. Not so sure. So I give you time to see whether this works. I'm trying to do is to replace two numbers in the matrix at the same time. It's not.
Mine worked, but they replaced 4 numbers.
Oh, there's some tricky part.
But I think I didn't put a space between the 99 minus 99.
You didn't put a space. You
Yeah.
put something. I don't know.
No, I just did 99 minus 99.
Oh, you put a number, so some
Right.
single number here.
No.
I put this one.
But minor zeros were 99. So it was 0.
Yeah. Yeah. So I'm trying to replace two numbers at the same time. Yeah.
It does actually work to index the two entries separately. So your A42, comma, A23.
Yeah. You mean this one here? Replace this?
Or you can just a comma right after the end parentheses that is the both.
Oh. But anyway, so I got confused. Normally I will maybe do a, yeah. Yeah, so this is a two-number indexing system against one number. Let me show you that again, that concept. If I have this, so I restore this. So my I can use two numbers to get 14. And if I use one number, say number 8, maybe number 8. I don't know, number 8 is 14 or number 8. I don't know the index.
It's you go
14.
down by you go down in columns to figure it.
By column first, yeah. So if you use a single number here, so that's number 8 by column first. So 1, 5, 9, 3, 2, 6, 0, 14. So number 8 is 14. It's the same as you gave the coordinates as 4 and 2. Okay. Yeah, so that's exactly next section here. So here they extract the value from the matrix and then replace it with a new number. That's what we did. Okay, this section is to extract three elements from row 1 to 3 at column 2. So if you do this, see, A is this. I want to extract 2, 6, 10. So that I'm going to do is to A from row 1 to 3 and the column 2. Okay. So this column means then you do. So when you see 1, 2, column 10, so this give you a list 1, 2, 3, 4 to 10. So here 1, 2, 3 means it's 1, 2, 3. So A is this, so one, two, three, column 2. Okay, so if you do 2 to 4, so this gave you 2 to 4 here, yeah, gave you a sub matrix with that index from the original matrix. Okay. And this operation just extracts the whole row. So if you think in expression matrix, if the row are the gene and the column are the cells, I would say, okay, can you give me the expression of numbers, the gene number 3, so that's the row number 3, and all the cells expression. So you will get the values from all cells expression for gene number 3 in this way. Okay. So this gave you a series number with the steps jump. So by 10, so this one you start from 0 and step 10 and until 100. Okay, I think that's already enough for you to start. So you have once you have the matrix in there and you know, okay, I can extract this and I get values. I can extract, see, column 133, that's a number 133 cell, and it's all the expression. I can have the profile for that cell, or I can have a number 11 genes expression across all the cells that give you the distribution of gene expression level across cells. Okay, you know those basics. And once you have the matrix in, so you can look at different genes, look at different cells, okay, in this way. Yeah, question, Alex.
Can you explain the command where you had A and then you had 2 square brackets inside the 4, 2, comma 2, 3? I'm trying to figure out which element of the matrix that's selecting.
Yeah, so if you have, so this is a row 1 to 1.
Not this one. It was when we were trying to rewrite the elements into 99 negative 99.
Oh, but that wasn't a success. I don't know.
Right, but I just got rid of the overriding and I was trying to figure out which elements I was choosing.
Yeah, so that's one.
Yeah, so if you got rid of the equals 99 part. And then just,
Yeah, you want to see this?
yeah.
I think it will be number 4 will be 13, and number 2 will be 5, 5, 3.
Yeah, it's not what I'm getting if you input it.
Oh.
Yeah, I'm trying to figure out what it's.
I don't know what's the behavior. I never.
Because if you get rid of the 2, 3, so you just do A 4, 2 in the square brackets, you get something else as well.
Let me think about this behavior.
Yeah, I was trying to figure it out. I've been trying to figure out what it's like selecting.
Yeah, for this, the first.
Because if you input just A and then inside the square brackets 4, 2, you actually
Get 14.
you get 13, 15. you get another number.
Oh,
Yeah.
six, 7. I I got confused. I don't know.
Figure out how it's taking the numbers.
I don't know. Where well, I don't know. I don't know.
Yeah,
Believe me, I've been working on this language for many, many years. I still don't know.
probably not gonna matter, but I was just curious.
I'm curious too.
See what it would give
Yeah,
me, and
yeah.
I couldn't make sense of it.
Yeah, yeah. In the program, I try to avoid this. Either I use this coordinate system with 2 numbers normally.
Yeah, that makes sense.
Yeah.
It's just if you put another matrix pretty much inside of
Yeah.
the thing, yeah. I mean, because you should try it with just the 4, 2, and it gives you a completely different number.
Yeah.
Yeah. Oh, that one makes sense because it's just the 4th element.
4 and the 2. Yeah.
But then.
Yeah. Yeah, become these 4 numbers. Believe me, I don't know. Okay, so the rest of time we will work through those lecture slides and looking for the equations, and then we play with that. Okay, can anyone try the norm function? So we have a vector 3, 2, 5. Let's see. In principle, this should be the vertical vector in order to be standard data science data point. But for the convenient, and normally just people leave this like that, it's easy to print, right? The norm function is, okay, so that's norm function. I think let's use let's use 2 dimension. So if I have a point like 3, 2, that's my point A. Right, that's my my data, single point. I would see, so that's 1. So, you know, there is a unit circle here. So now your job is to find this point here. This point on the unit circle point to the same direction of this. Okay, basically you normalize this back to its unit circle. So how can you do it? Give me the coordinate of this. So we see, okay, this is the point A. See, this will be the point B. This point B is A's projection on the unit circle. So this B should have an X and Y. The B is on the unit circle because a x squared plus y squared square root, this should be 1, right? This guarantee is on the circle. So these two numbers have to be satisfy the relationship of this towards the same direction. So in order to get this, we need a norm. We need to know how long this is from the origin to here. Okay. So the norm is, so we know it's 3.6056. So we know the norm. And then we have to do is divide every element here by this number. Then you will get the coordinates of B. Okay, so this operation gave you the value of B. We basically normalize this back to its origin. And the B gave you only the direction with the unit length. It gave you the information where the direction of this A is. That's only information without the, so it's normalized, scaled back to unit value. So you remember this way, okay? Now you can try, see, B, the first element of B squared plus B, the second element squared, and the sum of this should be 1, okay? Because it's on the unit circle. Of course, you can do square root. It's 1. So this concept, this operation is very important. You can omit this dot here because we know the norm is a scalar, it's a single value. It doesn't matter you have a vector divided by a single value. By element or not by element is the same. Again, this is not required, this dot element-based operation, but I just put there for the safety. I'd like to do that. Yeah, so this is important. And any given value on the space, please find me its projection onto the unit circle, the position. And this B vector is the direction, tell you the direction of your data point. Okay, so that's unit circle, the definition. Any point on the unit circle have this feature, okay? Now it's your time to type this in and see the multiplication between A and B. and whether so A and B normally not equal to B times A. You cannot change the order, not like scalars. So now we have A multiplied by B. Can you do B multiplied by A? So A is a 2 by 3 matrix, 2 by 3. So that's A. B is 3 by 6. Remember, in order to have these two matrices can do this multiplication, you have to have the match about this so-called inner dimension. So you can do A, B, you get answer of 2 by 6. And there's no way you can do B times 3. So because B is 3, 6, now you have a 3 here, a 2 here, a 3. There's no way you can do it because there's no one-to-one match. Is not compatible. So in your MATLAB, if you want to do B times A, you get error message. Not doable. So no. But because you have this example, so you know exactly what that means. This is 3 different kind of sandwiches. So that's why you can match them internally. But in this case, there's no meaning of this multiplication. Have you tried this? So this answer is that's what A and B, okay? Let's see if I can do decomposition to if I gave you A and B and the product, would you be able to do anything to find out the original? That's a question I asked during the class, right? So if I have a C, see this C is the product of these two, 24, 16, 15, 6, 4, and then my question is I need to find the two unknown matrix and their product is this. I never tried, but I haven't tried this, but let me see. I can get numerically correct. This must be positive. That's right. Let me see. I need to check the use of this function. K must be a no larger than, okay. I ask to, yeah. There are some conditions that we have to make this work. Yeah, basically, this tells me this problem has some condition which not doable by if you don't give any construction restrictions of the possible values. So I try to make this have more samples, because if you only give me one time of your shopping list, I won't be able to. You have to do this multiple times. So day one, you and your roommate give you a list, and day two, you do. And then once you have enough samples, I probably can figure out. So in this case, I duplicate the input, and so that allow me to make this work and get A and B, and the production of these two is very close to real value here. The 24, 24, it's doubled. But A and B is somehow normalized, so it's not what you expect to see. Okay. The scale towards. Okay. Let me see whether we have something else. Oh, yeah. So I think this we have to do after the break, 5 minutes, and we'll come back to finish eigenvalue, and then you start to work on your project. All right, 5 minutes break. Okay, the first question for you right now is, we have a data point like 1, 2, and please normalize it and found its projection on the unit circle. So if I have this point here, 1, 2, vector is from origin to it, and in the middle of this vector, this straight line, and you have an intersection and across this unit circle. So what is the coordinate for this point? Please give me the number if you can easily type that in the chat. So my number is number 1, 2. So first I need to compute the length of this from origin to here. So the length is A1 squared plus A2 squared square root, right? So that's how long this vector from origin to it, the distance basically. And this is the norm, right? Now, in order to compute this origin to the unit circle, it is the value 1, 2 divided by this norm, right? Okay. So the solution is this. So I know if I need a number to if I need this point on the unit circle to give me the direction of my point 1, 2. So this direction is 0, 4, 7, 2, 0, 8, 9, 4, 4. Okay. Now, the operator we are talking about here is 1, 2, 2, 4. So we treat this squared matrix as an operator. This operator applied to data points to change the direction of this the data, changes the angle, changes the and also rescaled it. And because of this relationship, let me see. So we have to normalize this. So we know if, so let's see, this is a B. But we know there's a relationship, which is if I apply A to this B. So I'm going to do something for this right point here. Oh, B has to be vertical.
Because you did B based on the 1 by 2 element for matrix, and then you said your new matrix says capital A.
Yeah, capital A is 2 by 2.
Right.
So if I have capital A is 2 by 2, so I need, so this is 2 by 2. That's my operator, and I need my data. So right now my data is 1 by 2. And you see this inner dimension not the same. So you cannot do it. So I have to make the data into a 2 by 1. So that's my B. Right? Now I can compute a new value. The new value will be 2 by 1 as well. So what I have to do is to make B a vertical. So this not work, but I have to make this vertical. This is my new number. So now I just replace B with its vertical. So make this A times B this, okay? And if you compare the A times B with B itself, you will see, okay, this product, if you normalize it, if you think this as a norm it's the same as a B itself. So what that means is I found the B and multiplied it, and once I normalize it, it come back to the same. So basically, you don't change the angle. You have no rotation on once you apply A to this number. You only change its scales, okay, by a number. So that's why the product of this operation, once you normalize it back, it come back to the same place in the unit circle. So that's the idea about we will see the B is eigenvector. Eigenvector means B is a special data point regarding to the effects of apply A as an operation. So that's a little bit not so straightforward. So you have to think it the way, like you use a data point as a feature descriptor to describe A as an operation and what the A behavior will impact the other data points. Okay, so that's why if we do the eigen, and you will see V is this data point is this eigenvalue. It's eigenvector. So this value is the same as a B, right? Right? So in this example, we start from a data point. We know it is an eigenvector. We normalize it back. We just play with this. But if you select any other point, you don't have this feature because this is special. It's a very special direction. Okay. If you still have questions, we can keep talking about this in the following weeks. You can discuss with your classmates and think about this, and there are another documentation, a lot of other textbook. Just make sure you know this, and this is a very special data point, a special vector regarding in terms for this A as an operator. Okay. On the other hand, this another point 1, is just general points, nothing special. Okay, now we switch our gear from this language issues back to this toolbox. Make sure if you do which CDGEA. So CDGEA is one of the function to change the working folder to gene expression analysis toolbox. So if you have this installed, if you can find this, and you know you already installed your package. Otherwise, you have to add this folder into your parse, search parse. If you don't have this installed, for example, you change your computer, you can Google and go back to this quick installation and just copy this. This code will download the source code, unzip it, then you have it. Okay, once you have this, remember last time we can use this interface to get some published data from a geodatabase. If you have this accession number, you can select this option and then put that number in here. And they should be able to have your data to start with. Now it's your job to find publications and identify this number, geo accession number, from the paper. And see whether you can have your data in there. So we don't play with the same data set. Okay, everybody has your own research interest, your domain knowledge, your research field. Found a paper you think is interesting to you and identify the ID. And do this, see whether you can get this smoothly. If you don't, if you have any problem with that, let me know the ID. So we will look at it together to see why you have the accession number. For what reason you cannot streamly download this data. Yourself, this is local data or already published on?
I just have to load it off my flash drive. It's not published.
Okay, so if you have your own data, I don't know what format it is, so you have different options. If you want to try, say, local file, you have MTX, or maybe you have a 10S genomics folder. I show you how to do it. You can load your own data. Certainly, there are different options. This one here, MAT file?
It says it's MATLAB data.
I don't think you have MATLAB data because you haven't used this before.
Well, I got this from Dr. Munyuka.
Oh, Munyuka, he already make this MAT files. Okay, so he's one of the user of this tool. So yeah, so in that case, if you have a MAT file, that will be easy. Just load it. Now I give you time to find the accession number from a paper and see whether you can load it. Okay, so we have one question from the chat. Maximum size of, yeah, so they are, so nowadays the matrix become larger and larger. So we do have some limitation due to the computational resource. So it really depends on your PC and see whether you have enough memory to load some larger data set. But normally, if you have more than 10,000 genes and up to 40,000 of cells, you'll still be able to make it. So I have a limitation, say, I would see 20,000 genes by 20,000 cells. That would be okay. We should be able to do it. Maybe 30,000 genes sometimes. 25,000 cells. So once you have this accession number, you may want to Google and find a geodatabase record. In this case, for example, if you found the ID with this GSE, and this is not ID for that particular sample, it's a collection of 9 different samples. So if you browse into this page, you see, okay, there's no matrix files. They only have this raw data, and we cannot process this. So in this case, you have to go into individual samples. Say, I will select one of the sample and look at here. There clearly the matrix file is here. So this will be usable. I will copy this ID of this sample and give this ID to the program instead of the top ID for the collection of different samples. So I have to be very specific. It's better if you can see this matrix in your record. So if you have an ID, you want me to try here together, you can type that into the chat. So we can try together here. Okay, so really, and just give us one of the example. Let's see. So I will first make sure. So this is from alcoholic female mouse, and from a protocol. Okay, so we have matrix, we have feature, and it looks like this data set generated by the 10x Genomics. So we can tell because they have a special name of this these files. So let's try with this ID. So I shut down the original old one. Now we are going to try this ID provided by Rally. You know, every page, the authors publish the data, they rename it sometimes. So we may have trouble to parse through all these pages. But I tried my best to make it compatible for most of the case, I believe.
So if at the bottom of the GSM website, it only has text, the text file, you won't be able to use those?
You can still, if they published rather than the MTX file, the matrix, they did the text file, and if that's a correct format, I will be able to, the program will be smart enough to do that. Yeah. Yeah, if this data set is too big, I won't be able to load onto this machine. In that case, I have to find another server. Say in the cluster, there's some in some of this server in on the campus, we can do that. There's a larger memory. Yeah. I know error. So yeah, let me see. So this you know, looks like they're well, it's pretty messy. So the parser don't know which file to download. Yeah. In that case, you may have to manually see. So what do you think? You will think this will be the one that you can copy the link. You copy. I don't know how to copy the link. Right click and yeah, copy the link, and then use instead of use this automatic, you use see. I have a link to text-based, so I just put that link in there. and see whether it works. Yeah, you have similar problem.
Different problem.
Yeah.
Maybe I just can't.
Yeah, so some papers they have a
So is it the raw count data? Can I
mhm.
read that in?
I don't think so.
What about the
Yeah, you can go into there. They then see whether they provide a geo link because that's a raw data.
uh-huh.
Yeah, so that's a FASTQ. Sometimes they just don't give you the processed matrix.
Right.
Mhm.
Thanks.
Yeah. Yeah, for this, they just provide not a standard.
Okay.
There, yeah, so just take some time to figure out what exactly they put in there. But normally you should be able to do it. Okay, there always have exceptions. So in that special case, you just not be able to automatically load that. In that case, your programming skills will be useful, and you have to look at this to solve a specific problem in the file, whether they have a non-standard format or there's something wrong with the file itself. So we don't know. There are many possibilities. For really this case, you have the data in there. So you see the range I just gave to you. So that's roughly we can have this easily load in. I will do this very quick filtering to get rid of those empty cells. Oh, it's here, this button, the first option. My computer is slower than normal. I hope you can get it sooner than what I can hear. Okay, I got the data cleaned up a little bit. Basically, removed a lot of gene expression level is too low. The quality of those sequences is good, so we still have a lot of cell left. In this case, I want to check whether the name of the genes has been correctly assigned. So here I want to see, yeah, so I know those are the mouse genes. In this case, because I have already spent so long to get this data, I want to save it as an MAT file locally. So next time I can reload it. So I just gave the ID for this. Okay. This mouse alcohol, some kind of alcohol. So I know next time what data they're having. Okay, so next, let's start to do embedding. With so many cells, and this process will take 4 to 5 minutes at least. So I will just let it run, and you will work around and to see what the program you made. I use top 2000 highly variable genes, save time. Those genes are mostly informative to make the input matrix smaller. If you really have a problem to load a specific data set, you may want to change it to another, or maybe you just use example data I provided. Nothing wrong with example data, as long as you get familiar with this procedure. Okay. So after this step, because this step also time consuming, so I want to save the information. Right? So I save the file again. Okay, now, as we mentioned last week, we are going to cluster cells into small groups because we have so many cells, and I will make a lot of small groups. I would say 60. The button is this tree-like button, so to make clusters. Yeah, so see those small cell islands and they become independent clusters. So that's what I want. And then I click this button to start to assign cell types automatically to small looks like they're all neurons. You will get a lot of neurons in different states, different type of neurons. Okay, I have a lot of subcluster from the neuron group. So I merge them into a same group. Okay, now I can click this button to see, I want to see the different cluster into new figures ordered by the number of cells. Oh, something wrong with the program. Okay. So I have to go back and check why there's error message here. So this function we cannot use at this moment. Okay, so I think today we just finish here. Depends on the question, and I believe this for this study, people are interested in the neurons. So we may see we want to extract select cell by cell type. We will extract neuron and progenitor neurons. I don't know these cells, but if they are useful, you can include. But now I'm going to extract these two cell types out, and we will do downstream analysis specifically working on those neural and neural related cells. Okay, so I extract the cell I'm interested in. So that's my original, and that's my new. So I save this as a new data set, neural only. And I can focus on those. And I can do subcluster for those. And they use my markers to tell different type of neurons later. Okay, so that's my this week's our practice, and we will continue next week. Okay. Any questions for online students from online students? We're all good, then we will see you next week. Oh, by the way, I do give the first homework in, I use Google Classroom to track your homework. The homework is simple, just take a short video and explain the multiplication of two matrices, and also explain the 10x genomics barcoding system using your language to explain to some people, strangers. And this video can be very short, and just send me the file of your video. That's all. So I know, okay, you can explain this by using your language. I hope everyone knows how to take a video and save it as a MP4 file, something like that. And the Zoom has a function, so you can record what you're talking about. And then the whole point is show me you know what we discussed during the class. Okay.
I couldn't get the video to save on my laptop.
Yeah, you can save to your laptop, but you send me a link or something. I can.
It wouldn't save, but I tried it. I can try again. If not, I can try on my actual computer or just take a photo video or something.
Yeah, anything. Just make sure I know you know what's going on there.
Yeah,
Okay, you can.
I got everything to work from last week except for the video part.
Okay. Yeah.
Is it okay to visualize a whiteboard or something, or just?
Yeah, whiteboard, whatever format you like. Yeah. Okay, see you next week. Thank you.